You are watching AliAziz Quality Education YouTube channel.
Propeller and BSc Aircraft Maintenance Engineering Technology, AMET, by AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry-related videos. So don't forget the subscription button.
The propeller is one of the key subjects in the Aircraft Maintenance Engineering Technology, AMET, program. It deals with the principles, construction, operation, and maintenance of propeller systems used on aircraft, both fixed-pitch and variable-pitch types. Propellers are used to convert the rotational power of the engine into thrust, enabling the aircraft to move forward. This subject helps students understand the aerodynamics, mechanics, and control systems of propellers as well as their inspection, balancing, and overhaul procedures in accordance with aviation maintenance standards. Objectives of subject propeller. To understand the basic theory of propeller operation and thrust generation. To study the different types of propellers and their components. To learn the construction, materials, and balancing of propeller assemblies. To gain knowledge of governing systems and feathering mechanisms. To understand maintenance practices, inspection methods, and safety procedures related to propellers. Main topics covered. 1. Fundamentals of propeller theory. Basic principles of aerodynamic thrust. Difference between air screw and propeller. Angle of attack, blade pitch, and thrust relationships. Propeller efficiency and factors affecting performance. Comparison between propeller-driven and jet propulsion systems. 2. Types of propellers. Fixed-pitch propeller, simple, lightweight, and low maintenance. Ground-adjustable propeller, pitch adjustable on the ground only. Variable pitch propeller, blade pitch changes during flight for better performance. Constant speed propeller, automatically maintains selected RPM. Feathering and reversing propellers, used on multi-engine and turboprop aircraft. Contra-rotating propellers, for improved efficiency and reduced torque reaction. 3. Propeller operation on different engine types. Propeller use on piston engines, direct drive or reduction gear. Turboprop engine propeller systems and reduction gearbox. Integration of propeller control with engine power lever and governor. 4. Propeller construction and materials. Hub assembly and blade attachment methods. Blade construction. Solid wood. Metal, aluminum alloy. Composite materials, carbon fiber, fiberglass. Blade root, shank, airfoil section, tip, and leading/trailing edges. Protective coatings and erosion-resistant materials. 5. Propeller pitch control and governing systems. Hydraulic and mechanical propeller governors. Operation of constant speed unit, CSU. Relationship between engine RPM and propeller blade angle. Propeller feathering system, reducing drag after engine failure. Reverse thrust system, braking during landing roll. Overspeed and underspeed control mechanisms. 6. Propeller balancing and vibration. Importance of dynamic and static balancing. Causes of propeller vibration and imbalance. Methods of balancing. Static balancing using knife-edge stands. Dynamic balancing using vibration analyzers. Troubleshooting vibration problems and damage identification. 7. Propeller maintenance and inspection. Routine inspection intervals and procedures. Visual checks for cracks, nicks, corrosion, and erosion. Checking blade tracking and pitch angles. Lubrication and servicing of hub mechanisms. Propeller ground run and operational checks. Safety precautions during propeller maintenance. 8. Propeller overhaul and repair. Repair limitations and approved workshop procedures. Replacement of damaged blades and seals. Balancing after repair or reassembly. Non-destructive testing, NDT, for cracks and corrosion. Record keeping, tagging, and airworthiness release certification. 9. Propeller controls and safety devices. Pitch lock system, prevents excessive pitch change. Feathering pumps and accumulators. Propeller synchronization systems, multi-engine aircraft. Ice protection, de-icing, systems using alcohol or electrical heating. Governor safety checks and failure prevention. 10. Propeller regulatory standards. Propeller certification and airworthiness requirements under EASA Part 66 Module 17. Manufacturer's maintenance documentation, overhaul manuals, OHM, service bulletins, SB. Logbook entries and release to service procedures. Maintenance planning according to airline and MRO policies. Airplane practical training/workshop exercises. Students perform hands-on activities such as propeller blade angle measurement, static and dynamic balancing exercises, dismantling and assembling hub mechanisms, inspection of blades for defects, propeller pitch change simulation, functional checks of governors and feathering systems. Importance for AMET students. Builds a strong understanding of aircraft propulsion systems in piston and turboprop aircraft. Enhances practical maintenance and troubleshooting skills. Provides knowledge aligned with EASA Part 66B 1.1 module requirements. Strengthens employability in airline, MRO, and propeller overhaul workshops. Career relevance. After completing this subject, students can work as aircraft maintenance engineers, B1.1, turbine/B1.2, piston aircraft. Propeller technicians in overhaul workshops. Maintenance and quality inspectors in MRO organizations. Field service engineers for propeller manufacturers. Powerplant maintenance planners in airlines or maintenance bases. Conclusion. The propeller subject is a critical component of the AMET curriculum, bridging the gap between aerodynamics and mechanical maintenance practices. It equips students with comprehensive knowledge of propeller systems, including their operation, balancing, control, and maintenance. By mastering this subject, future aircraft engineers can ensure efficient performance, reliability, and airworthiness of propeller-driven aircraft, vital for both general and commercial aviation.